My name is Higgs and this is my friend Boson. Welcome to the Higgs world.
Thanks for the introduction, Higgs. In this presentation, our goal is to offer you a quick summary of the research and conclusions. We follow inquiry-based learning model where students take lead in learning.
First, they get a quick review of the research via the videos. Second, they review the paper to learn and understand key concepts. Finally, they can follow up with further research on their own to dig deeper. In the end, students would have learned something new, latest and relevant. Isn't that wonderful, Boson?
Great point, Higgs. Please follow the links to review the research in further details. We want to thank all the authors and publishers for making this research public, thereby advancing science and innovation. Please like, share and subscribe.
Today, we are reviewing a paper titled, From the Martian Surface to its Low Orbit in a Reusable Single-Stage Vehicle, Charon. One of the first future steps on Mars will be to establish a permanent human presence on the planet by setting up a colony. However, a continuous supply of humans and materials is needed in order to build, maintain and grow such a colony. A sustainable and reusable transportation method between Earth and Mars must thus be available. This will likely require spaceships to be constructed in Earth orbit, without landing capability. This article looks at feasibility and design study of a launch vehicle whose mission is to shuttle crew and cargo from low Mars orbit, to a colony on the Martian surface. A single-stage reusable rocket has been selected to fulfill this mission, codenamed Charon.
The mission profile of such a vehicle was created, leading to a maximum growth allowance Delta-V budget of 6.2 km per second. With the mission profile in mind, each subsystem underwent a preliminary design. With reliability and maintainability in mind, subsystems were designed for redundancy and modularity, and an abort system was included for an added level of safety. The iterative design process resulted in a vehicle with a maximum growth allowance mass of 198.7 tons, capable of transporting 1,200 kg of cargo and a crew of 6 people to a 500 km orbit and back. Wonderful, Higgs. It is concluded that Charon is a reliable and sustainable vehicle for the given mission purpose of transporting crew and cargo between the surface and a low-orbit node, promoting autonomy in the operations of a Mars colony. The program for its development and deployment is technologically and financially feasible. Wow! That is amazing, Boson. However, it is a vehicle that requires significant prior infrastructure on Mars. This infrastructure is unlikely to be present by 2040. As far as timelines, operations are thus unrealistic to be expected by 2040, and more likely starting around 2050. Considerable infrastructure is necessary on the red planet for such a vehicle to operate. This vehicle is thus deemed to be practical for operations only after a sufficiently developed colony has already been established on Mars.